Welcome to the second day of solving systems of linear equations by the substitution method. Substitution method is where we substitute or replace the y in one of the equations with what equals y from the other equation. So let's review what we learned in the last lesson. Right? See if you can do it without my help. Pause the video. So if that 3x equals this y, it also equals that y. So you can replace that y with it, all right? Because we're looking for where, whoops, instead of that y, right, I'm supposed to write 3x. So we're going to substitute that 3x where y is, and then we're going to solve. We get 5x equals negative 5. This one's nice and easy. X equals negative 1. Now that's only the x coordinate of where those are two linear functions, where they cross. To get the y, this one's easy because you just put it in either equation and you get y equals 3 times negative 1 or equals negative 3. So these two lines intersect at negative 1, negative 3. Negative 1, negative 3 is the one and only combination of x and y that makes both of them true, right? It also works for the other one, right? 2 times negative 1 plus negative 3 does equal negative 5, right? It's the only combination that makes both equations true. All right, so then today we're going to be doing a little more advanced version of the same thing. It's the same method. And we're going to have to remember how to distribute, especially distribute a negative, right? When you have this situation, you're distributing a negative 2 here. So we have 11x minus 6x plus 12. Negative 2 times negative 6 equals 32. Combine our like terms. 5x plus 12 equals 32. Subtracting 12 from both sides. 5x equals, what is that, 20. Divide by 5. I'm running out of room. X equals 4. And right, that is the answer, 4, right? That's not a system where two lines are crossing. That's just a one variable equation where we're finding the solution. X equals 4. Okay. All right, so what's going to happen today is the same rule, right? If this x plus 6 equals this y, it also equals that y. But now the coefficient of that y is no longer 1. It was positive 1 in every single problem yesterday, which has made them easier. But so we're going to have to multiply 3 times x plus 6. And most importantly, you're going to need parentheses and distributive property. So try this one. With the hints I've given, you should be able to do it without my help, truthfully, right? So we're going to substitute, right? We're going to substitute, we'll use a different color just to show it. Negative 2x plus 1 for the second y, right? Well, whenever we have an equation to solve with parentheses, our go-to method is distributive property. I'm distributing that 2. I get negative 1x plus 2 equals 5, right? 3 minus 4x. Subtract 2 from both sides. Negative 1x equals 3. Divide by negative 1. And x equals negative 3. That's the x coordinate where these two lines cross. I'm going to put it in the top equation. Negative 2 times negative 3 is positive 6 plus 1. And the point where those two lines intersect is negative 3, 7. And negative 3, 7 better work in the other equation as well. Let's see, that's negative 9 plus 14. Negative 9 plus 14, is that 5? Yes, it is. Okay, that's the solution. All right, so let's practice. So that goes in there. X minus 2, right? And we're going to put the 3x plus 2 right in there. So we're distributing a negative 2. X minus 6x minus 4, right? Negative 2 times 2. X minus 6x, negative 5x. Adding 4 to both sides. Negative 5x equals 10. Divide both sides by negative 5. X is negative 2. All right, so we have the x coordinate. Now we're going to get the y coordinate. I'm going to use the one on the top, the slope-intercept equation. And 3 times negative 2, negative 6 plus 2 equals negative 4. And so these two lines intersect at negative 4. And we could put it in the bottom one to check that. Try this one. So we have x minus, and we're going to put that top one in parentheses. And it doesn't have any, there's no magic about which one's on top. If these were upside down, you would do it exactly the same way. You would still substitute the 4x plus 17 in for this y. Now, what do we have to distribute here? We have to distribute a -1. I like to write it in at that point. Right, so x minus 4x minus 17 equals 1. We get x minus 4x, negative 3x minus 17 equals 1. Add 17 to both sides. Negative 3x equals 18. Divide by negative 3. And x equals negative 6. All right, so I'm going to put it in the top one. I like to use slope-intercept when I do this. If it's available, 4 times negative 6 plus 17. That's negative 24 plus 17. Negative 24 plus 17 is negative 7, yes? And so they intersect at negative 6, negative 7. Okay, now, there's no magic about getting substituting for y and getting x first. You can substitute for x when it's more convenient. Now, so let's look at this, right? We have x by itself. Now, we could rearrange that and subtract 13 from both sides and get the y by itself and then do it like we've done all the others, but that won't be the fastest way. The fastest way is now we're going to substitute this for x, right? And this is where we get to see if you really understand why this all works. We're replacing this 2y plus 13 that is the same as this x as that x, right? So we're going to put it where x is. Now what's going to happen here is that you're going to get the y coordinate first. And you have to realize you're getting the y coordinate first. So it's still distributive property. 10y, 13 times 5 is 65. 10 minus y is 9y, so I have 9y plus 65 equals 38. Subtract 65 from both sides, okay. So let's turn that upside down. 65 minus 38, borrowing 7. Oh, we get 27, but because it's 38 minus 65, it's negative 27. Divide by 9. The y coordinate is negative 3. So let's make sure we understand that. That's the y coordinate, right? Y equals negative 3. So we're still going to put it in the top one. So the top one is not in any known form of a linear function, but it is still a linear function. And so we have 2 times negative 3, negative 6, plus 13. I think that's 7. And so this, make sure we put the 7 first, because that's the x coordinate. 7 comma negative 3 is where those two lines intersect. Okay, so here's a little hint in my notes. You can do it more than one way. I like to do the substitution and get that done and then clear my fraction. So let's do it that way. Other ways do work. So we have 2/5 x, all right. So 3 times 2/5 x, that's 8x plus, right, 3 times 2 is 6. 6/5, that do not make it a mixed number. That will not be helpful. All right, now you could combine like terms here and get 11/5, but let's assume that we didn't do that. But you absolutely could add those together, right? But let's just multiply everything times 5 and let's clear our fractions, because that's typically what I do. All right. Oh, look at that. We get 11x equals 55. Divide both sides by 11. X equals 5. So the x coordinate is 5. I'm going to put in the top one, even though it has fractions in it, because look at that. The 5 is going to cancel very nicely, and the y coordinate is 2. Let's try that again. So we have a fraction there. I'm going to put that where y is. All right, so it's x plus 2. I'm going to put that in parentheses, equals 14. So we have x divided by 3 plus 2, right? Distributive property. So this is x plus, you can say 2x over 3 or 2/3 x, either one. 2 times 2 is 4. Those don't cancel. You're doing distributive property, right? Equals that. All right, I'm going to get rid of that 3, although I could also combine like terms. So I'm going to multiply everything by 3, both entire sides. Those cancel, and we get 3x plus 2x plus 12 equals, 3 times 14 is 42. 5x plus 12 equals 42. Subtract 12. 5x equals 30. Divide by 5. X equals 6. All right, so the x coordinate is 6. Let's put it in the top one. right? And that is 6 divided by 3 is 2, plus 2 is 2. It's 6, 2, where the two lines intersect. Is that right? I don't think that's right, because I'm looking at the bottom one, and it's 6, 4, right? It's 2 plus 2 is 4. See, this is why you check your work. I just noticed that the bottom one didn't add up to 14, right? The bottom one's left side didn't add up to 14. I had made a mistake right there. It's 6, 4, right? Because I was looking right there. 6 plus 2 times 4 is 8 equals 14. That checks it out. Perfect example of why you should check your work. Okay. So, again, you can, on the fractions, I said substitute and then clear. I have found that clearing your decimals first is a little bit easier with these. So I'm going to clear my decimals first. And once you do that, then you do it all the same way. So let's see that. So we have that clears to 2x plus 2y equals 14. And then I'm going to substitute the top one into that. I sort of combined two steps there. All right. But I made this 2x plus 2y equals 14. All right. Now, could you have cleared it later? Yes, absolutely. I just found this a little easier. So distributive property, 2x plus 6x, 2 times negative 13, negative 26 equals 14. 8x minus 26 equals 14. Add 26 to both sides. 8x equals 40. Divide by 8. X equals 5. So the x coordinate is 5. And we're going to put that in the top one. 3 times 5 is 15. Minus 13 equals 2. Those intersect at 5, 2. So weirdly, I like to clear my decimals right away. With the fractions, I like to wait and clear them once I've done the substitution. Let's practice some more. Oh, there's some more decimals. Right, so if let's remind everyone what you're doing when you do this is you're multiplying both entire sides. You're multiplying both entire sides by 10, right? And that's why you're allowed to move the decimal point. And so this becomes 2x minus 5y equals 30, right? And we're going to substitute in. Notice in every problem today, you need a distributive property. Yesterday we didn't need distributive property because outside here was a 1, a positive 1. 2x minus 5x, negative 5 times negative 12 plus 60 equals 30. Negative 3x plus 60 equals 30. Subtract 60 both sides. Negative 3x equals negative 30. Divide both sides by negative 3. X equals positive 10. And here you do 10 minus 12 and you get negative 2. Let's make sure that works. In the bottom one here, I can use the one without decimals, totally allowed. 20 plus 10, yeah, negative 5 times negative 2 is plus 10 equals 30. It checks. Okay, so we have 6x plus 2, and we're going to put negative 3x plus 10 in there. And we get 6x minus 6x plus 20 equals 20. Well, that's here. We get 0x, also known as 0. And so we get 20 equals 20. What does that mean? Oh, look at what I said. Solve the systems and describe the lines. All right, this means there are infinite solutions. Okay, whenever you get that, that's infinite solutions. But what does it mean about these two lines? They're not parallel. If you said that, think about it. All right. It's how many times they cross. They cross infinitely. It's actually the same line twice. Yeah, and let's just see that a second. All right. So let's say I add 3x to both sides here. Well, I would get 3x plus 2y equals 10. All right. If I take that and multiply everything by 2, what do I get? I get the bottom equation. So I concealed that they were both exactly the same line by making an equivalent equation. And I did it two ways. I put it in standard form, and right, I took the one in, what I did was I wrote one in slope intercept. Then I put it in standard, then I multiplied it all by 2 both sides. If you multiply it by 2 both sides, you get the same exact graph, the same exact line. It's just disguised. Okay. And all right, so there's a fraction in there. I said deal with the fractions after you distribute. Okay. So I'm putting that in there. And I'm going to go, right? So when we multiply 5 times this negative 2/5 x, those 5's cancel, and you get minus 2x. And we get 5 times 4 is 20. This time we get 0x, we get 20 equals 5. Well, that's nonsense. So this is no solution, right? That's what that means. And in this case, what does it mean about the lines? This is where they're parallel, because they never intersect. Good luck with the homework.